So for one sample t-test, like the research question is going to come in form of, let me say something like us or a physician said that the average COVID-19 death count, with putting the start date and then the end date is 100 per entry. That's regardless of the sex, regardless of the age. So per day is 100. Now, once we carry out one sample t-test on this particular variable, whatever we get from the p-value will determine whether that is significantly true or not. That is, whether there is a significant difference between they call it hypothesized mean, between that and this particular variable, the mean of this particular variable. So that's what we want to do now. A t-test, one sample t-test. So for one sample t-test, we'll be using this variable wholly. I can also choose this as well. Yeah, I can choose that as well. But let me go with that alone. It will still be the same interpretation for both anyways. So let me add normality, effect size, descriptive. So from the hypothesis, the test value is not the same thing as the hypothesized mean. Like, that is, both this variable and the hypothesized mean, they are not the same. There is a difference between both. So that hypothesized mean is 100 in the example I cited. Now this is the mean, the median. These are the descriptives, data and information. And now this shows it is most likely not normally distributed. A low p-value suggests a violation, so it violated the assumption of normality, which shows that it's not normally distributed. Like normally distributed in the sense that the way normal curve on graph used to be. So this value is telling us that it's not like the normal curve on graph. It's either close to one side than the other, using skewness and kurtosis to also buttress that. Now, this is COVID-19 death, and the p-value is less than 0.05. So that shows that it's not true that we have 100 deaths recorded per day based on the research question I gave earlier. So that is, it is statistically different. It is significantly different. So that is what it means. It's not the same. So in this case, we reject the null hypothesis. And the effect size, 0.3, close to 0.2. So there is a small effect between the test mean and the hypothesized mean. So there is a little effect size between them. So that is for one sample t-test.